Hello students, welcome to maths class. In triangles, we have already discussed about congruence of triangle. We have learned about SAS congruence rule or axiom. So today we are going to discuss about SAS congruence rule and solve some problems based on both SAS congruence rule and ASA congruence rule. So let's get started. Let's prove the theorem SAS congruence rule, which states that two triangles are congruent if the two angles and included side of one triangle are equal to the two angles and the included side of other triangle. Let's consider triangle ABC and DEF, in which angle B is equals to angle E, angle C is equals to angle F, and side BC is equals to side EF. So given in triangle ABC and DEF, angle B is equals to angle E, angle C is equals to angle F, and BC is equals to EF. We need to prove that triangle ABC is congruent to triangle DEF. Here we are going to use SAS congruence rule to prove that triangle ABC is congruent to triangle DEF. To prove this theorem, we shall use SAS congruence rule. To apply that, we have a side which is equal, we have an angle which is equal in the two given triangles. But we need one more side which has to be equal to apply SAS congruence rule. So, in this case, we may come across three cases. That is, first case wherein we can take that side AB is equals to side EF. The other case, side AB may be greater than side DE, and the next, side AB could be smaller than side DE. So let's check in all the three cases to prove the theorem. So let's begin with the first case. That is, case 1, let AB be equal to DE. So in the given triangles, if AB is equals to DE, then in triangle ABC and triangle DEF, AB is equals to DE, that is assumption. Angle B is equals to angle E is given, and BC is equals to EF, and that is given. So triangle ABC will be congruent to triangle DEF by SAS congruence rule. That is, two sides and included angle of one triangle is equals to two sides and included angle of the other triangle. Now next case, when side AB is greater than side DE. This case 2, let AB be greater than DE. Now to make the side AB equal to DE, so that we can use SAS congruence rule to make the two triangles congruent. So to do that, let's do some construction. So let's mark a point P on AB such that EP is equals to DE. Let's mark a point P on AB such that BP is equals to ED, and join the point AC. So that will be our construction. So mark a point P on AB such that BP is equals to DE, and join PC. Then in triangle PBC and DEF, side BP is equals to side ED by construction. Angle B is equals to angle E, which is given, and side BC is equals to side EF, again it is given. Therefore, triangle PBC is congruent to triangle DEF by SAS congruence rule. Now, angle PCB is equals to angle DFE by CPCT, but angle ACB is equals to angle DFE, which is given. Therefore, we can say that angle PCB is equals to angle ACB because both the angles are equal to the same angle DFE. So these two angles become equal. This will be possible only when B coincides with A. That is, when AB is equals to DE. Therefore, AB must be equal to DE. This implies ABC is congruent to angle DEF by SAS congruence rule. Now let's go for case 3 when AB is less than DE. Now here side AB is less than side DE. Now to apply SAS congruence rule, we need one more side which is to be equal. For that, let's mark a point Q on DE such that AB is equals to QE and join the point Q and F. That's a construction. Now in triangle ABC and QEF, side AB is equals to side QE by construction. Angle B is equals to angle E, which is given. That is angle ABC is equals to angle QEF, which is given. Then side BC is equals to side AF, which is again given. Therefore, triangle ABC is congruent to triangle QEF by SAS congruence rule. Now, angle ACB is equals to angle QFE by CPCT. But angle ACB is equals to angle DFE, which is given to us. Here you can see both the angles are equal to the same angle ACB. So, angle QFE will be equal to angle DFE. This is possible only when point Q coincides with point A. That is, angle QFE will be equal to angle DFE only when point Q coincides with point F. That is when AB is equals to DE. This implies triangle ABC is congruent to triangle DEF by SAS congruence rule. Hence proved. So with the help of SAS congruence rule, we prove that if two angles and included side of one triangle is equal to two angles and included side of another triangle, then the two triangles are congruent. Now, look at this figure. Here, in these two triangles, that is triangle ABC and triangle DEF, two angles and a side of one triangle is equal to two angles and a side of another triangle. But equal sign is not included between the equal angles. So will the two triangles be congruent in this case? So let's check. Now you see, if these two angles are equal, then the third angle naturally must be equal because angle sum property of a triangle, since the measure of the third angle in both the triangle is equals to 180 minus the sum of the other two angles which are equal. The measure of two angles will be equal. So then this angle will be equal to this. That is, angle A will be equal to angle D. Then you can see here the given equal side will be in between the equal angles. So we can understand that the equal side need not be between the equal angles always. So the equal side need not be included between the corresponding equal pairs of angles. So two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equal. This is called AAS or SAA congruence rule. Now let's solve some problem related to SAS and ASA congruence rule. Example 3. AB is parallel to CD and O is the midpoint of AD. We need to show that triangle AOB is congruent to triangle DOC. Also, O is the midpoint of AC. The solution given AB is parallel to CD and AO is equals to OD because O is the midpoint of AD. Now, we need to show that triangle AOB is congruent to triangle DOC. Also, CO is equals to BO. Solution in triangle AOB and DOC, AO is equals to DO, which is given. Angle AOB is equals to angle DOC, which is nothing but vertically opposite angles, and angle ABO is equals to angle BCO, since AB is parallel to CD and BC is the transversal. Therefore, triangle AOB is congruent to triangle DOC by AAS congruence rule. Now, since AOB is congruent to triangle DOC, OB will be equal to OC by CP CT. This implies O is the midpoint of BC. Next, let's solve some exercise problem. Moving on to exercise 7.1. First problem. In quadrilateral ACBD, AC is equal to BD and AB bisects angle. Show that triangle ABC is congruent to triangle ABD. Solution given in quadrilateral ACBD, AC is equal to BD and bisects angle A, that is angle CAB will be equal to angle DAB. What we are supposed to show is triangle ABC is congruent to triangle ABD. Now, solution. So, we'll take the two triangles which we are supposed to prove they are congruent or show they are congruent. Now, for solution, the given triangles which we are supposed to show are congruent, we will check for equal parts. So, here you can observe in triangle ABC and ABD, as one side is equal, and here these two angles are equal. So, we got one side, one angle. So, we need another side. So, this is common to both the triangles. So, we got two sides and an angle. So, this is how first you are going to check. Now, for solution, we'll take in triangle ABC and triangle ABD, AC is equals to AD is given. Then angle CAB is equals to angle DAB because angle AB bisects angle CAB and AB is equals to AB, which is common. Therefore, triangle ABC is congruent to triangle ABD by SAS congruence. This is the axiom. So first part of the question we have answered. Now one more sub question is there. What can you say about BC and BD? So what can we say about side BC and BD? They are nothing but corresponding parts of congruent triangles. Hence they will be equal. Therefore, BC will be equal to BD by CPCD. Now let's move for next problem. ABCD is a quadrilateral in which AD is equals to AC and angle DAB is equals to angle CBA. We need to prove that triangle ABD is congruent to triangle BAC. That is one thing. Again we have BD equal to AC and angle ABD is equals to angle BAC. So these three things we are supposed to prove. Solution. So let's write what is given. In quadrilateral ABCD, AD is equals to BC and angle DAB is equals to angle CBA. This is given to us. Now we need to prove that triangle ABD is congruent to triangle BAC. BD is equals to AC and angle ABD is equals to BAC. Angle BAC. For proof, in triangle ABD and triangle BAC, we are going to consider these two triangles now. In these two triangles, AD will be equal to BC because it is given. Angle DAB will be equal to angle CBA. Again it is given, equal angles. Now AB will be equal to BA, which will be common to both the triangles. Therefore, by SA congruence rule, the two triangles, that is triangle ABD and triangle BAC, are congruent to each other. Since these two triangles are congruent to each other, BA will be equal to AC by CPCD. Again, since triangle ABD is congruent to triangle BAC, angle ABD will be equal to angle BAC, again by CPCD. Hence we have proved AD and BC are equal perpendiculars to a line segment AB. We need to show that CD bisects AD. That is, we need to show that OB is equals to OA. Now given AD is equals to BC and angle BAO is equals to angle CBO, which is equals to 90 degree. Since AD is perpendicular to AB and BC is perpendicular to AD, we need to show that CD bisects AB. That is, BO is equals to AO. We need to show that these two triangles are congruent. Then by CPCD, we can say that the two sides are equal. So let's show these two triangles are congruent. Solution: in triangle BCO and ADO, angle BOC is equals to angle AOD, vertically opposite angles. Angle CBO is equal to angle DAO, which is equal to 90 degree. Given AD is perpendicular to AB and BC perpendicular to AB. BC equals to AD is given. Therefore, triangle BCO is congruent to triangle ADO by AAS congruence rule. This implies OB is equals to OA by CP/CT. Then O is the midpoint of AB. Thus, CD bisects AB. So today, proving ASA congruence rule, we also learned that AAS and SAA congruence rule is also satisfied, and we have solved some problems related to it and SAS congruence rule. That's all for now. Thank you, students.